Hey guys, welcome back. So, if you remember last week, we were talking about a whole bunch of foundational concepts related to statistical concepts. And it was a lot of puzzle pieces that I gave you that sort of, I bet a lot of them, if I'm drawing from past student information, a lot of that stuff probably felt like, okay, I understand this little piece and I kind of get this piece and I'm confused about this one. And it was a whole bunch of information. And what I'm going to try and do today is really bring it together so you can put those pieces so we can see the bigger picture here. That's what we really want to get to. And it's going to come together, I think, pretty quick. And then we're just going to look at several different examples of what this means in clinical practice. Okay. The following week, this is the beginning of part 2 of our 3-part series. The following week, we're going to look more at reliability and validity and that kind of stuff so we can build in more of those foundational pieces. But I wanted to kind of come together today, okay? So we went through this process, just to prime the pump a little bit here. We went through the process of looking at the calculations from raw data, understanding the basics of, one person's score. We did talk a little bit about correlations too, but one person's score through measure of central tendency, you do a little calculation, then you get the variance and the standard deviation, and we left off right about there, okay? Where we're going to pick up today then is we are going to talk about we're going to skip a little bit of the math, not just because. I don't know why, because I think because at one point I was like, well, we don't need to cover everything. I don't want to overwhelm everybody. But we're going to skip things like calculating z-scores and how to do that because it really just gets kind of more complicated. It's hard to show the math. And if you're not going to practice it, then there's really no point. But we can go from standard scores to things like z-scores, and ultimately we'll get to t-scores and percentiles. Okay, so that's where we're going to kind of pick up the story today. And then I'm very quickly going to start talking about the normal curve and what those pieces mean. And this will really start to come together. Before we do that, I'm going to introduce these concepts behind me here, which are criterion reference scores and norm reference scores. Because once we start talking about things like t-scores, we're going to have to know what kind of data we're talking about in terms of being able to explain this. And remember, just to reiterate this again, the whole point we're doing this is to be able to make good clinical decisions. And then eventually we're going to be able, and part of that process eventually is to be able to talk to our clients about what this information means and how do we do something with it? Why are we making the decisions we're making? Okay. So this is another of those puzzle pieces that will help us with that. There are these 2 categories. It's a little hard to see because there's a lot of numbers going on over here, but there's 2 categories. One of them is a criterion reference score, and another one is a norm reference score. When we think of criteria, we're measuring a person against a certain kind of information, a certain standard of performance, a certain kind of information, a certain, we want to know how much you know. So here's a few examples. When you take your final test in this class and you do that study guide kind of thing, or you take your NCE test, we're measuring you not against what other people know. We're measuring you against a set of information that we think represents what the minimum standard is for you have to know this much in order to be a counselor. So it doesn't matter what other people score. It matters how much of that content you know, how much of that content domain or the construct of what a counselor is. If we were giving you a driver's test, we don't care how you compare to other drivers on the road. We care how you compare to how much of the rules you know, how good of a driver you are against the standard of what good driving looks like, right? Okay, so when we're talking about criterion reference, I'm not going to talk about these subpoints up here because that'll just get more confusing, but something like the PHQ or the GAD-7, these are criterion reference scores. It doesn't matter how much other people are depressed or anxious. It matters how much you meet the symptom criteria. So those are all criterion reference scores. Many different kinds of tests that we're going to use are more like that because we don't really care about whether other people are depressed. We care whether you're depressed against that kind of information, okay? Norm reference scores, on the other hand, those are measuring you against another group of people or other kinds of test scores based on how other people score. Norm reference scores are way more, I would say they're way more common in terms of how we're going to talk about what we're going to talk about here. When we're doing these complicated assessments, we're going to be using mostly norm reference scores. Okay, so I want to explain what the norm is. Most of you probably know this, but I'm going to go through it just as a review for all of us, just to kind of get our heads in the same place, because we're going to need to use this when we get to the normal curve. A norm group is, remember when we were talking about, what was it? What were we talking about? We were talking about the very beginning of last week about inferential statistics, and I gave you the example of, shoot, now I have to go back in my memory. By the way, this was a week ago for you. This was an hour ago for me. I'm wearing the same clothes that I was for last week because I'm doing these back to back. And I still can't remember what I talked about an hour ago. That's pretty bad. It's kind of embarrassing. Maybe I shouldn't tell the story. I shouldn't even tell you guys that, because now I'm embarrassed only because I brought it up. I didn't even need to say that. I could look smarter if I didn't open my mouth, right? Just kidding. Okay, so I gave you the example of doing a survey of all Americans on all 50 states. And I said, let's take one person from California, one from New York, one from Nebraska. And then we need to get a representative sample. So we're going to get a male and a female from every state. And then we're going to get somebody from every ethnic group, and on and on and on, right? That example of getting a representative sample is important for doing statistics. In a very, very similar way, a norm group is a representative sample of all the people that have taken the test in the past. The way it's slightly different, and only slightly, is that if your score is going to matter, we want to make sure you're within a group of like individuals. So I'm going to give you a stark different example so that we can make sense of what the norm group really is supposed to be like. Let's say I want to be evaluated for, let's see. I'm trying to think of a good example. I'm not thinking of one at the moment. Let's say someone gave me a test on how good I was at, we'll use my recipe example from last week of baking. I want to bake a cake. And I go through this test and I score 6 out of 10 or something. Follow all the instructions and out comes my cake and I get a 6 out of 10. And I find out that compared to other people, I scored very, very low and I'm not a good cake baker. And I say, oh man, that's so discouraging. That just seems like, I should have scored higher. I thought I did an okay job or whatever. And I look into how the test was developed. And when the test was made, the test maker said, well, who bakes cakes? Well, women bake cakes. Traditionally in America, it's a woman's job to be in the kitchen. It's being very sexist, by the way. And this is an awful example, but using it just as an example. So they essentially, the test was sort of practiced on a bunch of women. But I am not like a woman. I don't identify as a woman. So I'm being compared against a group that doesn't really fit who I am. In other words, the results don't show up the same. So it's not really fair to measure me against a test that was normed or created or fit to be to score people in a really different way. Let me try and give you a better example. That was a really stupid example. Here's a better one. Let's say I gave a medication. We'll use a drug example. These tend to be easier. I gave a medication to a whole bunch of adults because it's going to cure people's freckles. You're going to give people this pill and it's going to take all their freckles away. So I gave it to a bunch of adults and it cures all their freckles and it does a wonderful job. And then some kid comes along who's this tiny kid, and it worked on adults and everybody was safe and everybody's healthy, 0 side effects. Can you imagine that? And this kid comes along and he says, well, try it on me. I have freckles and I want them to go away. And the doctors say, well, okay, we'll try it. And the kid, I don't know, he gets more freckles or whatever. The example that I'm trying to explain here is that you can't really compare the results of one child against a bunch of adults, or one man against a bunch of women, or more relevant to what we're talking about here, if you give I don't know, like one ethnic group, if you say like these people are tested for their cold resistance, and they live in Georgia, and that doesn't really help a lot. These examples are really stupid. I'm not coming up with good ones off the top of my head, but the norm group is essentially the foundation of how the test was developed, and it's unfair to test somebody outside the norm group because you're essentially comparing apples to oranges, not apples to apples, or like they're the normal group. So if you are considered non-normal, then the test may not be a good fit for you, or the results may be kind of skewed. In other words, with my example that I started with about baking the cake, I scored low because not because I'm a bad cake maker, but because I was measured against the wrong group. Another really stark example that I gave you, I think I talked about this maybe in the first week, or maybe it was last week. I'm not really sure. 2 weeks ago, I'm not really sure, but the example of the GRE. The GRE is potentially biased against certain kinds of people, typically African Americans, because many African Americans live in urban areas and live in depressed socioeconomic statuses. And so it wasn't testing intelligence as it was intended to. It was normed on people who have means, and it just wasn't really functioning. It was unfair, essentially. I think I've done a really crappy job of explaining what norm groups are, but I also think that probably most of you kind of know what these what these are. This is a little embarrassing, but I'm going to leave it in here because I'll just try again in class if it doesn't make any sense. Just ask me about this if you need to. But what I want to do in class is have a little conversation about diversity too. So if you think there's something important here to bring up about, do these tests really make sense for people if the norm group doesn't fit? And how do we then use these tests if it's not the right tool for the job? So we'll talk a little bit about manipulating tests and accommodating for different groups and that kind of thing too. I talked about the issues in norming, the geographic representation, cultural representation, etc. The other thing that I want to tell you about is this thing called the Flynn effect. I think it's kind of interesting. I don't know if this is something you have to know. I think this kind of thing will show up on tests. You'll read about things like the halo effect and the Flynn effect. These are all kinds of interesting psychological phenomena that happen. This is one that relates to assessment. So the Flynn effect essentially is the intelligence testing has been happening for a long, long, long time. Okay. The IQ scores of people have changed over time. And it's really interesting because if you took the average IQ score today, by the way, we'll go through this in a little bit, but the average IQ score for every single person is 100. 100. The average IQ score for every person, the mean IQ is 100. If you were to take that score and give the exact same test to people 100 years ago, they would score a whole lot less than us. And the question is, are people actually getting smarter, or is our standard of intelligence increasing globally across all people? Think about it this way. 100 years ago, in 1925, there were a lot more people that did not go to college. They didn't even pass high school, let alone go on to college, let alone to go on to get master's degrees. A lot of people were on homesteads, they were farmers, they were working the land, and they didn't have to have all these really intellectual pieces of knowledge to function, right? Does that mean that people were dumber, or they just needed a different set of tools to adapt in their world? Well, that's the question. Is intelligence, and ultimately our intelligence tests, measuring the things we need to know about intelligence, or are they measuring this unrealistic standard of information that determines how smart we are? The Flynn effect essentially says, now that I've made that explanation, the Flynn effect essentially says people appear to be increasing in their IQ scores over time, which means, it sort of seems to mean that people are getting smarter. However, the reason I bring that up in this section is because the test gets re-normed every so often, and it has to. Otherwise, it looks like people are just getting off the wall or off the charts smarter, and it skews the data, and we wouldn't have good averages to work with. We wouldn't be able to compare people the way we need to. So we have to reevaluate norms periodically in order to make sure that the tests function because of this thing called the Flynn effect. It seems to change what the norms are because people appear to be getting smarter, even though there's a whole debate about whether that's actually happening or not. So anyway, interesting stuff, but only semi-relevant to what we're talking about here. Okay, so now let's get back to our conversation, and I'm going to flip back and forth between some pictures here, some of the pages that I pulled out of the book to be able to describe this stuff. The percentile score is probably one of the most important, if not the most important, concept that we've talked about this last 2 weeks, and that we're gonna go through a bunch of examples here, or not a bunch, but some examples here in a little bit to talk about this. That progression from mean to variance to standard deviation to the ones we haven't talked about, like z-scores and t-scores. We'll talk about t-score in a second here. But onto percentile. The percentile is when we really start to get into the territory where we're going to be sharing this information with clients, and we're going to have to kind of wrap our minds around what are we actually talking about here. In fact, just yesterday, I went home and my son, who's 7, was sent home a report card, and it wasn't a report card like it used to be with like the S for satisfactory, E for excellent, or an ABCD grade or something like that. It had some charts and it had percentiles on it, and it kind of said, compared to the national average, your son is above or below, whatever, So even this kind of stuff is being sent home. So I'm going to make the assumption, I'm just going to throw it out there, that probably some of us have seen these things and we kind of know what they mean, but we maybe also kind of don't. I'm also going to make the assumption, and I think this is based on prior knowledge, that clients typically don't know what this means. At least they don't know it in the context of counseling, the context of how to understand research and how to understand their scores and that kind of stuff. That's why we have to be really diligent and knowledgeable about how to describe this stuff to people. So I know I haven't described it yet, and I will here in a second, but we need to jump to our normal curve in order to understand that. We'll go on to standard scores too once we get to that part. So actually, let's do that right now. Let's jump over to our chart. No, don't scan, please. Okay. Sorry, excuse me, I have something in my hair. You ever get a hair stuck on your tongue and it's like not a big deal, but then you can just feel it. It's super annoying. I just had that. Okay. So what do you see on the screen here? You see a normal curve. You've seen these before. Most of you know what this is. It's the bell curve, the normal curve. Probably it has been a good hot minute since you've talked about one of these things or looked at them in detail. There's a few things I want to describe to you and for you to kind of memorize. We're going to go over this again and again several times and kind of repeat it to help you kind of sink in. But this is the normal curve. Everybody who takes a certain kind of test is going to fit somewhere on this graph. They're going to fit within this, right? Remember our calculations before? These ones right here? Sorry, make you sick looking back and forth at this. If I were to add all these up and divide by 5, that would get me my mean, right? That's this number right down here. Can I still do this? Yes, I can. That's my average. The average of all the scores added together and then divided by the number of scores, okay? That's represented by this X right there. When I go down to my normal curve, my little X is going to be right there. So this line right here represents average. When I calculate the variance and the standard deviation, I can know that a certain amount of the group of all the people taking a test, and let's kind of get away now from this example because this only has 5 students in it, but let's say I have 500. If I do those calculations, I can learn about something about the standard deviation. Now the standard deviation is going to be represented by each one of these lines right here, okay? So we have our average, and then we have one standard deviation below the mean, below the average, and one standard deviation above the mean or above the average. We can tell mathematically that all the people in the population, so again, not 5, but 500, out of all those 500 people, 34% of those people are going to score somewhere between one standard deviation above and below the mean. Okay, so now I'm going to go backwards. It's going to be bouncing around a lot. Let's pretend that last week we went through the calculation, and probably we did. Again, I'm playing a little bit of time travel here, so I'm doing these recordings back to back. A week after this, I'm going to give you this lecture, and we'll have gone through this mathematical equation. And remember this number right here, this 12.02 that represents the standard deviation of the difference of these scores. Well, that 12.02 is our standard deviation. So if we start to look at this chart, we can say with confidence that 34% of those 500 people are going to score 12 point, what is it? 12.02? Yeah, 12.02 points above average. Okay, what was average? Do we remember? 80. And 80 is represented by this line with or X with a line over it. So we have an average score of 80. Sorry, going back and forth here. There's our 80. And that means that one standard deviation above is going to be 12.02 points. We'll just round it off to 12 points above 80. So 80 plus 12 is going to be what? 92, right? 34% of those 500 people are also going to score 12 points below the mean, or one standard deviation below the mean. So 80 minus 12 is 68, okay? So that means that of all those 500 people, 34% are here, 34% are here. If I add 34 plus 34, that gets me to 68. So 68, where's my big, all this moving around. 68% of all the people of 500. What's 68% of 500? Somebody do that math really fast. I don't know what that is off the top of my head. But that many people are going to score somewhere between the score of 68 and 92. So that's really helpful information. So if I go back to my original scores and I look at this kid number 5, which we did in our example, kid number 5 scored 62, okay? So 62 is lower than 68. Sorry, I just do the math in my head again. What we can do then is we can calculate what is not just one standard deviation or 12 points below average, but we can go 2 standard deviations to know how much further down is this person, okay? So let's take that. Let's do the math. 80 minus 12, so 1 standard deviation below the average is 68. 2 standard deviations below 80 is 68 and 56, right? His score was 62. So 62 is going to fall right on this line that I pre-made somewhere, right? It's going to fall right in there somewhere. And so this person is roughly 1.5 standard deviations below the mean. And we know the number for the standard deviation because we could calculate it based on our equations that we used. The reason that is helpful is because that then can give us something related to a percentile score, okay? Now, percentile scores are not in your book in the easiest way readable. I don't think I have them. Oh yeah, percentile scores are here. The way that these work, and this is when it really starts to get helpful and interesting. Okay, now let's take this fresh normal curve here. The normal curve is always going to stay the same. It's not going to look different. The percentiles, or the percentages stay the same. 34, 34, 13.5, 13.5. So if I take this normal curve and I fill in my number 80 for the mean, and I take his score 62, and I go down and count this down, I say, how many standard deviations was this far below the mean? And I do that math. And then all I have to do is draw this imaginary line straight down here. And I learned that roughly speaking, this is very inexact the way we're doing it now, but roughly speaking, this person scored in the lower 5th percentile, okay? So this is an example of how you look at percentiles, how you can read those. I'll tell you what that means in just a second, but I want to flesh out this percentile idea, what this actually is. If I am absolutely right on the mean. If I score 80 points in a class of 5 people and people scored above and below me, just like you saw in that list of scores, and I scored absolutely on the mean, then I would be in the 50th percentile. And here's what percentile means. Percentile means if I score on the mean, then half of the class is above me, or 50% of people are above me, and 50% of the people are below me. If I score 62, like in our example, that means that I'm at roughly the 5th percentile, or maybe we could say the 6th. We'll just say 5th for sake of example. If I'm at the 5th percentile, that means 5% of the class scored below me and 95% of the class scored above me. Okay? One more example real quick, and then I'll explain some more. If I score a score of, let's say 90. No, let's say I score, I don't know, 96 points. My mean is 80. My standard deviation is 12. So I add 12 to 80, which is 92. And I go up just a little bit more to 93, 94, 95, 96. And let's say I land, let's just pretend it's right here on this line. So 96 would be right about here because we measured the standard deviations, right? And I draw my line down. We'll do some more examples of this, by the way. I draw my line down right here, whatever. Based on this percentile line, and these lines don't change, I could know that I scored higher than 90% of all the people in the class and lower than 10% of people in the class. Another way of saying this is if I lined up 100 people and I put myself at the 90th percentile, 10 people would be that way and 90 people would be that way. Well, if I'm putting myself in there, then like 9.5 people would be that way and whatever, you get the idea. But so hopefully this makes a little bit of sense about what percentiles are for. Now, the reason we're doing this, remember, is because we want to change the information and manipulate it just in such a way that it tells us something that we can package into our brain that makes a little bit more sense. We want to manipulate the data and change it. Now, if I'm looking up here, if I say, well, you scored 62 on the tests, the person's like, well, okay, is that good? How many points is it out of? 100? No, it's not out of 100 points. It's out of, I don't know, 98 or whatever. You're like, well, so then is it 62%? No, it's not 62%. Well, then how do I understand what that score is? Well, that's when we can do the math and we can say, well, I can't give you your percentage on the, like how, I could give you just your percentage. It's how you guys get a lot of your test information is like what percentage of the test did I get right? But that doesn't help us with large groups of people and over time and over space, like I explained last week. So we use systems like this to help us understand how do I compare to other people. Okay, so that's one example. I'll go through more examples of how you talk about percentile, but the things that you'll want to remember, and this is really kind of universal, the normal curve is going to stay the same. The percentiles are going to stay the same all the time. The mean will change depending on your data set. And the standard deviations are always going to be represented lines like this, but what number they represent is going to be different based on the data. So in our case, it was 12. In other cases, it's going to be 5. In other cases, it's going to be a little different. So we'll look at some of those standard deviations in examples, and we'll talk about them in a little bit here. So we've now seen, what percentiles are. Now, I'm going to go back to my presentation here. Now we can look at standard scores. Okay, standard scores are going to be another thing that we're going to use, and we're going to see these a lot to be able to explain what individual scores are in different assessment reports, okay? This is one of those areas where it seems like it's super complicated and it seems like it's really convoluted and there's a whole bunch of language to describe different things, but really it's not all that complicated. And there's these really easy ways of explaining what this means. There's a little bit of memorization you have to do, but here's what I'm going to say first before we show you a picture, and you'll get it instantly because I know all of you can handle. Can you draw a relatively straight line? If you can draw a relatively straight line, then you'll be able to handle this, okay? It's really that simple. There are several different kinds of standard scores, and we're going to give them all different names, but they essentially kind of mean the same thing. Okay, so a go back. A percentile is a kind of standard score. A t-score is a kind of standard score. A deviation IQ or div IQ or just IQ. Those three all mean the same thing. Div IQ, deviation IQ, or just IQ score. It all means intelligence quotient. It's all the same thing. Stay9 scores, that's a short, fancy, jargony way of saying a standard 9 score. I'll explain what that is too. Or a STEN score, which is a standard 10 score. All those are standard scores. They're all relatively the same thing, okay? It might seem weird that I'm saying it's the same thing, but once you see this in a second, you'll get it. SATs, GREs, the NCE, these are all sort of, they have kind of standard scores to them. In other words, everybody is measured against the same score. So let me explain what this looks like in a picture, because that'll make a lot more sense. So come back to this one, flip over to the next page, page 119. So here is our normal curve again. Well, that drawing is not normal, but you get the idea. And I wrote in my terrible handwriting this percentile line, which is over on the page we just talked about. When I get that standard score, the calculation where we left off last week, part of the reason I left off is because the next step is essentially being able to make a z-score. It's kind of convoluted how you get to it, but you get a z-score. And then you take that, you turn it into a t-score. And you can also take those and turn them into like all these other versions of scores. And the way you do that, and get rid of some of this ugly stuff, the way you do that is you just take a straight line and you draw a straight line down this thing. There's mathematical ways to do this too, but this is probably the easiest way. You draw straight lines down here and you say, well, okay, based on what I know about standard scores and based on what I know about percentiles and t-scores, and if I have a certain kind of information, I can usually find other stuff. So let's use our example here. Back when we had our student who scored 62 on their example, what would that represent on this chart? Well, I know that my mean was 80. I'm going to clean this up a little bit. My mean was 80 and 62 was 1.5, roughly 1.5 standard deviations below the mean. So here's 62, and we found out that the percentile score was something like 5, the 5th percentile, right? So this person is also, we'll just skip the z-score because who cares? This person's going to get a z-score of roughly, it's not quite in the middle of 30 and 40, so maybe we'll say like 34. They're going to have a t-score of 40, okay? A t-score of 40. Now a t-score, the thing you can remember about t-scores, and the reason we use them is because they're always measured on a scale of 1 to 100, okay? Percentiles, you can, by the way, you can see how t-scores are evenly distributed across this normal curve. And what that means is that we like that because it has even distribution. Even separation across the normal curve helps us. That might be confusing the way I said that, but it helps us. See how these, when we're talking about individual people compared to other people and how many people are above and below them, we can't have it evenly distributed. And I know that's a little technical and technically the way we're talking about it. But when we're talking about percentiles, we can say how many people are above and how many people below if we lined up 100 people. In this case, we can't do that, but it does help us to talk about t-scores, because if we see a t-score of 60, we can know, just coming back here, drawing our line, that we can say this person is just on the high side of average, because remember, this 64% of the population fall between 1 standard deviation below and above the mean, right? So remember our scores before when we said if 80 is the mean and we have a standard deviation of 12, that means that 68% of the population fall between 68 and 92. If this person got a t-score of 60, we know that that person scored 92, and we also can use that to sort of place them on a certain kind of percentile, which we use over here, which would be like whatever it was, 85, 85th percentile, whatever we just said before. Okay. So if you're confused, that's okay, because you'll see this in a second. So just hang tight. The other thing I want to tell you before we move off of this chart is that uh, the number that you're going to see the most often is the t-score. That's the most common, the most popular, and percentile scores. Go away. Percentile scores and t-scores are going to be the most common. So what are all these other ones, you ask? Why the heck do we even have them? Why are there so many different names? Aaron, if they're all the same thing, why do we have so many? Well, the reason is because different kinds of tests have just, for one reason or another, become popular with a certain kind of score. So IQ scores, intelligence quotient scores, they always use the same standard score. Always, always, always. So if whether you're doing the Stanford Binet, or you're using Wechsler scales, or you're using the Slauson, or any of those, anytime you're talking IQ scores, you can always remember and memorize that anytime there's an IQ score, it's going to have an average number or an average mean of 100. So the reason that's important is because if you're gonna use IQ scores globally, and one test developer says, well, my average is 100, and the other one says it's 5, then someone says, oh, I have an IQ of 110, it's not going to make sense if they took a different test. So all the tests work on the same standard scale. It's been standardized. So anytime you hear IQ score and someone says, I have a 110, it doesn't matter which test they took. You can know that average is 100. And if you know that and you memorize the stuff about the percentages and the normal curve, which we're getting practice with, if you can say, well, I know they scored 100, and if one more piece, every IQ score has a mean of 100 and a standard deviation of 15. That means that every standard deviation goes up by 15 points. See that? If we do the math, and it goes down by 15 points too, over here. Can't do my thing, but goes down by 15 points. So a score of 110, we know that it's above average, and we also know that it's less than one standard deviation above the mean, which means that 110 might sound like that could be potentially significantly above average, but we know that fits right within average. It's not that far above, and it just sort of fits within is this person fit within 68% of the population? Yeah, fits right in there, just like slightly above average. So just to repeat, anytime someone talks about IQ scores, average of 100, standard deviation of 115, anytime IQ scores, okay? These two, STAY-9 or Standard 9 or STEN, Standard 10, those two are most popular in educational assessments, kind of like achievement scores, things like that. That's where I see them the most. I almost never see these in clinical applications, like clinical tests. But essentially what they are is STAY-9 or Standard 9 is a scale of 1 to 9. That puts 4.5 or 5-ish right in the middle. And so some people think it's easier to think of 5 as the middle. This one, some people think a standard of between 1 and 10 is easier to understand. But then that puts right in the middle, that puts 5.5. And so some people say like, well, 5.5 shouldn't be the average, it should be 5. We use a Standard 9 scale. And other people say, well, between 1 and 10 is easier to understand, so we're going to use a STEN scale. Just like it's a whole bunch of preference, really. So what you'll see then as we go to some examples here is you'll see oftentimes there's a few different scores. You'll usually get a T-score. Most often you'll see a percentile score. And then you'll also get a DivIQ or a STAY-9 or a STEN score or something like that. The SAT and the GRE, the reason this one's here is because it's popular enough and enough people know it, enough people use it, but the SAT has its own kind of thing, and it's on this same scale. The ACT, they have their own. I can't write that out right now, but that's supposed to be ACT. They have their own. It's like a scale of 1 to, what is it? I don't even know, 1 to 35, something like that. I don't even remember what it is. But they have their own standard score. But if I took any of these standard scores, and I put it on a chart just like this, and I said, well, if I know the average or the mean score, I can do some translation just using a really basic chart like this, or there are mathematical ways of doing it. You should use mathematical ways, but most of the time you're never going to have, all the time you're never going to have to do the math. You'll be given a report, and I'm going to show you those in just a second. But you'll be given these examples, and you can then do some translation to say, well, this is this percentile, and this is how it fits within the population. Okay, this is a lot of information coming at you really fast. I know that. So let me switch back to the slides just to get us reoriented before we go on and talk about some examples, just to make sure I'm covering things the way I want to. Yes, okay, so that's as far as I want to go right now. So let me show you an example here really quick. I know we're at 40 minutes here, so I'm not going to, we'll do more examples in class. This one is really gross to look at, okay? So we'll go through this in more detail in class. Oh, that is really ugly. I really don't like that. Sorry about that if that's really gross to look at. But here we have subject area, raw score, scale score, standard score, confidence interval, percentile rank, grade equivalent, age equivalent, descriptive category, okay? We don't know what this test is. Well, it's the key math. We don't even have to know what this is for now. We don't have to know everything on here, but let's just start kind of pulling out some information that we do know, okay? So what things do we know? We know a little bit about algebra. We don't really know what these raw scores mean because we don't know how this test works. We don't know all the functions of it, and that's kind of okay. We don't need to know all this stuff, right? If we're using it for clinical application and we're not giving the test to find out very specific information, we're just getting this from our clients or our students or whatever. The scaled score, we don't really know what that is either at this point. The standard score, what is that? Is that a T-score? Well, let's not make an assumption because we don't really know what that is. Confidence intervals, we'll go over those. I believe it's next week. We'll talk about what those are, so hold on to that for now. We're not going to go into that just yet. But we do know a little bit about percentiles. So let's just take that and we'll kind of glean some information out of that. We don't have a lot of them here, but we do have a percentile score for these basic concepts. So let's talk about what that percentile score is. If we go back up to our percentile chart here, and we go all the way over to the number 4. Here's the number 4 right here. And we were to draw a line straight up here. We could probably, let's just assume, I know this is not 100% accurate, but let's assume we're like right down the middle. Assume it's like right down the middle, just for the sake of making this simple. Because I have these two standard deviation lines here, and we know that that all this space underneath here represents 13.5% of the population of all people who took this key math test. Let's say we split that in half. What's half of 13.5? That would be like, let's do some round numbers here. Let's just make this 14. So half of that would be 7. So if this person scored in the 4th percentile, the words we can say here are that 3 people scored lower than this person, and how many? 96 people scored above him, or roughly something like that. So 96 people scored above him and 4 people scored below him, just generally speaking. We can also calculate the percentage of population if we want to. If we were to cut this in half and say that's 7, and we were to add this 7 plus this 34 plus this 34 plus this 34 plus this number, which we don't have here written, but we were to do all that math. If we were to do that, we'd come up with the percentage of the population that scored above him. Now, the percentage is different than the percentile. But the question the reason I show you that is that, does the percentage really tell us anything that we need to know here? It could, but it generally doesn't really need to. The percentile tends to be an easier, maybe not easier, but a more useful way to describe this. So the way that I've always described it to people is that I say, if you line up 100 people and you put them at the 4th spot, 3 people are going to be that way, and 95 people are going to be that way, okay? So that's how we can take that information and say, how does that how do we then understand where this student is falling on their understanding of basic concepts? This would be a place to kind of watch out for, okay? Here's another one, percentile rank of 39. We don't need to go back to our normal curve anymore. We can just talk about this and say, okay, percentile rank 39. That means that how many people go this way and how many people go that way? Well, they have at least 61 people who score above them and 38 people that score below them. I'm really testing my math abilities here a little bit. 38 people that score below them. And then likewise here, they're scoring relatively low on applications and total test composite. Okay, so we're already starting to pull out information from these kind of reports and finding something useful about it. Okay, so we'll get some more practice in class using these, and we'll look at some more examples. But I want to get onto a few more pieces of information that we're going to use for this specific table here. Okay, this next part, it starts to get a little easier from here, and then we're going to start really pulling it all together. Okay, we're going to do most of that in class. So we also have this other thing called grade equivalence. Let me jump back here really quick. This category is grade equivalence. This category is age equivalence. What do those things mean? Well, if I have a grade equivalent, what it means is that it tells me a little something about where this person is scoring compared to their grade placement. So it's intended to represent a student's test performance in terms of the grade level at which the average student's performance matches that of the examinee. What the heck does that mean? Let me explain that to you. Let me tell you how it works first, and then let me explain the language. That'll make more sense. So usually it comes out in a number very similar to this one. So let's take this number 11.4. And what that essentially means is this person is scoring the same as a person in the 11th grade in the 4th month. Okay? 11.4 means 11th grade, 4th month. What would the 4th month be? Well, if we start in September, September's 1, October, November, December, which essentially is halfway through the school year. So at the end of the fall term, this person is testing the same as what's sophomore? No, junior. That's embarrassing. A junior in the 11th grade, halfway through their school year, would be scoring the same as this person. Okay, so let's say I'm in 9th grade and I just started my 9th grade year and I get a grade equivalent of 11.4. That means I'm scoring the same as a 9th grader as the average student would score in the 11th grade halfway through their 11th grade year. Okay, let's just pick another number, 7.5. That's 7th year, 5th month. 3.8. 3rd grade, 9th month, or 8th month, sorry. So that's what those numbers mean. Age equivalents work almost the exact same way. This number 6.9 would represent a person who's 6 years old in the 9th month of life. And the way that's a little bit different is, let's say they were born in, let's take the 9th month. Well, what is the 9th month? January, February, March, April, May, June, July, blah, 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 blah. September. September is the 9th month, right? So a 6-year-old in September, or who was born in January, who's made it 9 months past their 6th year, that would be September if they were born in January. If I was born in September, it would be 9 months beyond that. Okay, so let's look at an example to see what that means. Back to my sheet here. Okay, so first of all, the thing we want to know is, how old is this person? By the way, you can't really see this, but this kid's name is Tommy Test Case. So Tommy, we don't have his ID number, but we do have some information right here. We do know that he's 7 years old and he's in his 8th month. We don't know his, well, we do know his, no, we don't know his birthday, but we don't really need to know his birthday. What you'll see on a lot of on tests that use this is they'll ask the birth date and then they'll ask you to calculate his age equivalent. In other words, if his birthday is in February and he's 7, 8, that means you count 8 months beyond February, which is March, April, May, June, July, August, September, October, and then you'd put 7.8 for his date. for October, whatever. So this person is 7.8. So you see a colon here, but that means the same exact thing. We also know he's in the 3rd grade. So now let's go back down to our basic concepts number here. We see a grade equivalent of 1.4. So if Tommy is in the 3rd grade and he's scoring at a 1.4, what does that mean? That means he's scoring the same as somebody who's of the average person who's in the 1st grade in the 4th month. What's the 4th month again? The 4th month is December, which means halfway through the school year. So essentially what that means is he's almost 1.5, 1.5 years behind in his understanding of this concept, because the average person in 1st grade halfway through the year is scoring the same as Tommy is now. Okay. So let's say that, let's use another one. Let's use this 2.9 here right below it. He's a person who's been to school he's in 2nd grade in the 9th month. What's the 9th month? September, October, November, December, January, February, March, April, May. So that's like the end of the school year. Notice you don't see any numbers above 9 because they don't do school in the summer. So the 9th month is essentially right up to 3rd grade. So it looks as if Tommy is right on pace. Like he's right up there with his peers in terms of mental computation. Okay. But he's behind in basic concepts. So you see the percentile, it seems really, really low, and that's maybe cause for concern. But then when you manipulate that data and change it just a little bit, we see he's a grade and a half below in terms of how he's doing with this kind of thing. Is that too far? Well, that's what we get to know, and that's what's helpful to know in terms of how much intervention we need to provide, something like that. Okay. Let's look at grade equivalents really quickly here. We're almost done, by the way. How long are we? 51 minutes. Okay, we're all right. So he is 7 years old. He's been alive for 7 years and 8 months. Okay, we don't know his birthday, but that's okay. We don't need to know that. 7 years and 8 months. In terms of basic concepts, the average 6.5-year-old, so someone who's been alive for 6 years and 6 months, is scoring the same as Tommy is. Okay, so he's been alive for 7 years and 8 months. This mystery person has been alive for 6 years and 6 months, and they're scoring the same thing. It's another way of saying that. So Tommy is scoring, for all intents and purposes, essentially 1 year lower in terms of age group. Okay, so he's like 1 year behind in terms of his age, 1.5 years in terms of grade, and in terms of his like peers, 96% of his age-related peers, people of his same age, are scoring above him. Okay, so those are 3 pieces of information. They look very different, but they're telling you essentially the same thing. But some are more helpful than others. The reason why we show you a couple different ones here, and by the way, go away. This thing says below average. That's true. This does give you some good language to use, some qualitative ways of describing this. But depending on how you use this information, how you communicate this to people, it can land a little bit differently. Which one sounds better or worse or more accurate? Compared to his peers, he's 96% of his peers are scoring better than him. It sounds different than he's a year behind in terms of his age, where he's supposed to be developmentally. And that's a lot different than in terms of what gets covered in class, he's about 1.5 years behind. So the reason we have these 3 different ways of describing this is because it's gives us more tools to describe how do we do something about this, and what do our parents need to know to understand where this kid is. Okay, so what we're gonna do is we're gonna go through some more examples of things like this, and we can flesh this out a little bit more in class because it'll be a little easier to talk about it when you guys bring your questions. So please do bring your questions. Tell me what makes sense, what parts were confusing, all that kind of stuff. So I'm looking at the clock here, and I don't want to make this go on any longer than it has to. Oh, the last part, we're almost done here actually. The last part is really these almost a ton of different tests give qualitative examples of if you score in this range, here's what it means. Oops. Here's what it means. If you score in this range, this is above average, below average, mild, moderate, or severe depression or whatever. And these things are really, really helpful, not only for our own understanding, but how you write about them in your reports. Which numbers do you use in your reports, and how do you, what value does this stuff have? Well, that's what we'll talk about when we get to communicating assessment results, and we can answer these questions in class too. But if you're talking to parents or you're talking to your clients, this category right here, sorry, let me clean this up just a little bit. If you're talking to other people, this category right here is often what they want to know and what people really care about and how they can really consume that information. It's the easiest, most accessible. Depending on whether if you're talking to teachers, they might be more interested in the grade equivalent because they know the curriculum, they know the content, right? If you're talking to parents, they might, or their physician or speech pathologist or something like that, they might want to know developmentally how and cognitively where are they at. In terms of percentile rank, any one of those groups might be interested in that kind of content. So part of the reason we throw all of these at you and why they look so complicated is because it gives you different tools and different resources to communicate in different ways. All right. So it's not intentionally meant to obfuscate or make it more difficult to wade through this or make it more confusing. It's meant to give you more tools to explain it in richer and different ways. So what we're going to do is take this information and talk about how do we then write it in reports? How do we then communicate it verbally? And what do we do with this information in terms of our own clinical decision making? Because what would I do with this? Well, we wouldn't use this one per se because this is a math achievement test and it's not going to help us in our clinical mental health applications. However, what we can talk about in class is we might talk about, this is a vocabulary test, so we'll just do an example with that. But this one here, this is the SCL 90, this is the symptom checklist 90. This has things like the mean, and we have clinical significance, and we have norm groups in here, and we have, this is a scale, this is essentially like a T-scale. And so we can glean some information out of things like this too. So we have T-scores down here too, and we're going to piece apart this information for clinical application later on. So hopefully some of these pieces are starting to come together. Was that our last slide? Yeah, that was the last one. Hopefully some of the pieces of what we started to talk about are coming together. There's still one or two more things that I want to tell you about, like confidence intervals, but we'll get to those next week. And what we'll do in class then is we'll kind of go through a bunch of different assessment examples and have you help interpret those and talk about them and explain them. And I can share some more things with you because I want you to come away from this with a real good understanding of how to read these things. And then we'll get more practice at like, how do you talk about them and what do you do with that kind of stuff? We can talk about that in class too a little bit. So anyway, hopefully this made a little bit of sense. I know it's a lot of information and it can be pretty intense. And if you didn't get all of it, I fully expect that to be the case. And that is A-okay. If you feel like you got none of it, then we can talk, or you can just come to class and we'll be okay. But please let me know if you have additional questions or whatever. So I'll leave it there. I'll talk to you later. See ya.